In this video, I'm going to look at finding the volume of the concrete required for the footings and the slab, and then find the total cost of all that concrete. So we have a rectangular house, which is measuring 18,000 by 12,000, and it has footings running around the perimeter. So those footings go around the entire perimeter of this building, which is effectively a trench dug within that perimeter that is then filled with concrete. And that trench is, as it says in the question, 350 millimeters wide. And if we look at, say, a cross section across the middle of this, we would have the slab, and then we're going to have our footings going down around the outside, and they are 450 millimeters deep. So the way I'm going to work this out is I'm going to split this top view into a couple of different rectangles. So we're going to have this rectangle across the top, which is exactly the same as this rectangle down the bottom, and we're going to have this rectangle down the side, which is exactly the same as this rectangle down this side. So I'm going to find the volume that is represented by the rectangular prism, which is this rectangle going here and then down 450 millimeters deep. And that'll give me the same as this volume here. And then this volume is going to be the same because we have this rectangular prism if we take into account the depth. So I'm going to call this volume 1, and I'm going to call this volume 2. So let's have a look at the first volume first. So we're going to have the first volume. So volume's rule is length times width times height, and that is going to be our length of 18,000, which is in millimeters, and so we should convert this to meters. So we have 18 meters, times that by the width of our footing, which is the width of our rectangle, and that's 350, but turn that into meters as well, is 0.35. And then our height, which is the depth of my footings, which is 450 millimeters, which in meters is 0.45. So if we multiply these out, we get 2.835 meters cubed of concrete just for that part there across the top. So then if we have a look at our second part, we have again length times width times height, but now my length is my 12,000 millimeters, but not all of it, because we've got this part of the footing and this part of the footing that we need to get rid of, because we only want this bit in here. So we need to get actually our length first. So before we go and actually calculate our volume, we want the length of section 2 first. And that is going to be 12 meters minus 0.35 off the top and minus 0.35 off the bottom. And so we're going to have 11.3 meter length. That is going to be for this section. So we're going to now we can calculate our volume for that section. So we have 11.3 times our width of 0.35 times our height, which is our depth of our footing, of 0.45. So we can now get our volume by multiplying these out, and we get a volume of 1.77975 meters cubed. Now I'm writing out all the numbers here just so that when we use this later, I'm getting an accurate answer. So now what we're wanting to do is find the entire volume of our footings. So to get the entire volume of our footings, we're going to want to take two lots of section 1, because we have the rectangle across the top and the rectangle across the bottom, and two lots of section 2, which is our rectangle for either side. So the volume of my footing is going to be two lots of volume 1 plus 2 lots of volume 2. So we have our total volume of our footings. So this is going to be 2 lots of 2.835 and 2 lots of 1.77975. So if we work this out, we're going to get 5.67 plus 3.5595 and add those together, and we're going to get 9.2295 meters cubed of concrete just for the footing. So now that we've worked out the volume of concrete required for the footing, we can work out the volume of concrete required for the slab. So if we have a look at the volume for the slab, we can then have our total volume of concrete, and we can find out how much it's going to cost us. So the slab is this 18,000 by 12,000 rectangle, which is 100 millimeters thick. So we're just going to have a length times width times height of 18 length, 12 width, and 100 millimeters is 0.1 meters. And this calculation will give us the volume of our slab. So the volume of our slab is 21.6 meters cubed. So now we've done part A and we've done part B. We've got the volume of our concrete, and now we can work out part B, which is the total cost of the concrete. So to do that, we first need the total cost of the total amount of concrete we have. So the total volume, I'm going to call it volume total, will be the volume of our footing plus the volume of our slab. And that will give us the total volume. So we're going to have our 9.2295 and add on our 21.6, and that will give us our total volume. So our volume total is going to be our 9.2295 plus 21.6, which gives me a total volume of 30.8295 meters cubed. And now finally, we can work out our cost. So the cost of our concrete is going to be our $150 per meter cubed cost. 150 times our total volume. So we're going to get our total volume and multiply it by our cost. So this is going to give me 150 times this 30.8295, and that'll give me a total cost of the concrete of $4,624.43, and that's it. So to work out the volume of the footings, we just work out the volume of that rectangular trench that is dug around the perimeter. Volume of the slab is just to find out the volume of rectangular prism, that's the shape of the building, and then to work out the cost, we just add those together and multiply by the cost of concrete.